Hello there and welcome to the October 2020 exam. Here we're on question 5. So a block has length r plus 2, width r plus 1 and height r centimetres as shown in figure 2. In a set of n blocks, the first block has a height of 1 centimetre, the second block has a height of 2 centimetres, the third block has a height of 3 centimetres and so on. Using the standard results for r cubed, the summation of r cubed, summation of r squared and the summation of r, to show that the total volume of all the n blocks is set by this expression here. So what we're effectively going to be doing in this question is we're going to be summating the all of these blocks here where r equals 1 up to n. So when r is the value 1, that's going to be a 1 by 2 by 3 block. Then when r is 2, that's going to be a 2 by 3 by 4 block. Then it's going to be all the way up to an r times, an n times n minus, so n plus 1 times n plus 2 block. So we're going to have to add all of these volumes up, because the way you find a volume of a cuboid is you times the 3 dimensions together. So it's going to be the summation of r plus 1 and r plus 2. So this is going to be, first of all, we need to expand the brackets. R equals 1 up to n of r cubed plus 3r squared plus 2r. Let's now split these up into 3 different summations. So it's r equals 1 up to n of r cubed plus 3 lots of the summation from 1 up to n of r squared plus 2 lots of the summation from r equals 1 up to n of r. Okay, so now let's do the summation on this. Let's now substitute in the summation formulas. So for the r cubed one, it's n squared over 4, n plus 1 squared. For the r squared one, it's going to be 3n over 6, n plus 1, 2n plus 1. And for the r1, it's going to be 2n over 2, n plus 1. Okay, the next thing we need to do now is we need to create common denominators, because that's going to help our next factorising step. So it's going to create common denominators out of 4 on all of them. So n squared over 4, n plus 1 squared, plus, this is now a half, so we could rewrite this fraction as 2 over 4, n plus 1, 2n plus 1. And the last one is going to be 4n over 4, n plus 1. Right, so now we have a big factorising step ahead. So we've got a common denominator on 4 on all the terms. N is also a common factor of all 4 terms, so all 3 terms. And n plus 1 is also a common factor of all 3 terms as well. So let's now put what's inside the brackets after we've done the factorisation of n over 4, n plus 1. There's going to be one more n on the first term and one more n plus 1 on the first term as well. On the second term, it's going to be 2. We've factorised out the n, we've factorised out the 4, we've factorised out the n plus 1, so it's just going to be 2n plus 1. And on the last term, we've factorised out the divide by 4, factorised out the n, factorised out the n plus 1, so we've just got 4 to go inside those brackets there. Okay, the next thing we're going to now do is expand what's inside the square brackets to see if we can now factorise it. So expanding it is going to be n squared plus n plus 4n plus 2 plus 4. Let's simplify this even more. So n over 4, n plus 1 is going to be n squared plus 5n plus 6 equals n over 4, n plus 1, and then factorise this, n plus 2, n plus 3. And there we are, 4, n is greater than or equal to 1. And there we are, that's the answer for this question here. N over 4, n plus 1, n plus 2, n plus 3. We've shown it, we've shown it there. So there we are. So make sure you've got lots of detail in your answer, because actually the result, this line here, is actually not going to score you any marks at all. All of the marks will be picked up in all the working that you've done to get to this point, because it's a show that question. Let's move on to part B now. So this is the volume of the blocks. Given that the total volume of the blocks is n to the power 4 plus 6n cubed minus 11,710, determine how many blocks make the setup. So remember here, n is a whole number, so it's in the z plus, and it's greater than or equal to 1. So if we get any other solutions other than a whole number that's greater than 1, then we just ignore it. So what we'll do then is, on this expression here, we'll expand the brackets. Given that the total number of blocks n is equal to this, so we'll expand the brackets, so n over 4, n plus 1, it was n squared plus 5n plus 6. Let's expand the brackets a little bit more, so n over 4, n cubed, and then it'll be 1n squared plus 5n squared, that's 6n squared. Then it's going to be 5n plus 6n, that's 11n, and then 6. And now we'll expand it all with the n over 4 at the front, so it'll be n to the power 4 over 4 plus 3 over 2n cubed plus 11n squared over 4 plus 3 over 2. And now this is going to equal n to the power 4 plus 6n cubed minus 11710. So let's now start moving everything all onto the same side. Maybe we'll move it all onto the right hand side, so it's going to be 3n to the 4 over 4 minus 6 minus 3 over 2, that would be 4.5, so it would be 9 over 2, plus 9 over 2n cubed, minus the 11 over 4n squared, and 3 over 2n, so it's minus 3 over 2n, minus 11710. So let's now substitute all of that into the polynomial solver. And let's just substitute that all in, and the only number that comes out there as a whole number is n equals 10. So therefore n equals 10 is our answer for this question here. So we've put all of this into the calculator, into the polynomial solver in our calculator. Polynomial solver, degree 4, this one is, and n equals 10 is the only number there that comes out to be a whole positive number. So there we are, that's the answer for question 5. That's worth 7 marks there. Let's now move on to question 6.